So in this lesson we're going to look at the quadratic equation and the discriminant, and the learning intention will be to learn how to identify the nature of the roots of a quadratic function. To be successful in this, you need to be able to calculate the discriminant, which is part of your quadratic formula. That's the b squared minus 4ac part, that's the bit under the square root, and use the result to identify the nature of the roots of a quadratic function. So we'll be mainly using your thinking skills to do this, your organisation skills, but also communication skills will be important in this. So just a wee quick recap on what you met yesterday. When we're solving a quadratic equation, which remember is an equation that's got an x squared, an x, a constant, and you've got this equals 0, then we're basically working out the points for the function y equals ax squared plus bx plus c, which lie on the x-axis. We're working out the roots when we do this. We've replaced y with equals 0 in that to get that quadratic equation. So the roots, right, are the points on the x-axis graphically. Now there are three possibilities for if you draw one of these quadratic graphs. It will either cross the x-axis at 2 points, or it might just come down and touch at 1 point, or there might be no intersection with the x-axis at all. So they're kind of your three possibilities. You can't ever get the graph to cross at more than 2 points, and those are the three standard situations that we will be thinking about. So we met this quadratic formula yesterday, this x equals negative b, and this big plus or minus square root bit b squared minus 4ac all over 2a, what that allows us to do is work out what these roots are. However, we can tell, if you like, in advance without working out the whole formula. Just if we just home in on this b squared minus 4ac bit, the bit that's under the square root, because if you think about it, if b squared minus 4ac turns out to have a negative value, and you try and do the square root of a negative number on your calculator, you'll find it doesn't exist. So that doesn't mean the graph doesn't exist, it just means that we can't work out any roots. And in that particular case, that would be this type of graph here. So the graph would be all above the x-axis and never ever touch the x-axis. So we can tell that just from working out the b squared minus 4ac part. So you also would have seen yesterday when you're working with this, if you get a value that is greater than 0, then you're adding and subtracting this value, so you produced the two root scenario. However, if b squared minus 4ac was equal to 0, then you'd have nothing to add or subtract on the top line there, and you'd simply end up with only one root or only one solution. So this, because that happens, this b squared minus 4ac is called the discriminant, because it discriminates between the different types of roots. So kind of, here's a wee bit of a summary of this. So if b squared minus 4ac, and remember that that is simply the bit under the square root, if that turns out to be greater than 0, you're going to get two roots. And what we say about the nature of the roots is that there are two real and distinct. Right, the word distinct means two different values, so two real and distinct roots. So if you get a question that asks you for the nature of the roots, this is what it's talking about. You have to work out the b squared minus 4ac. If it's greater than 0, then you'll get two real and distinct roots. If, however, b squared minus 4ac is equal to 0, then you get what's called equal roots. So the roots, and again you use the word real, the roots are real and equal, and in fact in that case you only get one real root. If the discriminant part, the b squared minus 4ac, is less than 0, then you're not going to get any real roots at all, and your graph would look like that. So on your notebooks, in your notes on page 33, you have got this 9.2b towards the bottom end of the page, and it tells you this information. So the discriminant b squared minus 4ac can be used to determine the nature of the roots. And there's the three statements I've just discussed. And then here's the nature part, the two real distinct roots, equal real roots, no real roots. So how do we use that? So you saw yesterday when you were working with the quadratic equation, that you needed to be able to identify these a, b and c. These are what's called coefficients numbers in front of each of these terms. So we're going to identify the a here for this equation would be equal to 3, the b would be equal to 2, and the c would be equal to 1. Now all you have to do here is then sub into the bit, the b squared minus 4ac, and we were already doing this, so this is just like starting off your question yesterday, but you don't need to go on and do find the actual roots. So in this would be me doing 2 squared, take away, and remember this is 4 times a, which is 3 times c, so all of that's getting taken away. Now most of this is going to be done in a non-calculator situation, so remember that they're all getting multiplied together, the 4 times 3 times 1. So 2 squared, remember, is 2 times 2, so that's 4, take away, 4 times 3 times 1 is going to give you the value of 12. Right, 4 minus 12, that's the same thing as thinking about 4 add negative 12, remember, which is in fact negative 8. So this is a scenario where if we were to plug that into our quadratic formula, we'll get error on the calculator. Right, so clearly that is less than 0. So it's this next bit that's quite important. You need to communicate correctly. So you need to make a statement, and what you need to be saying is, since b squared minus 4ac is less than 0, there are no real roots. Okay, and that's your communication part. And you get, when you do this in the exam, you get a mark for this. So you would need to have worked out your value and got to the negative 8. You should then notice that because that is less than 0, that tells you there are no real roots. So the second example, right, the same thing again. Right, we compare with the ax squared plus bx plus c. So picking out, first of all, your a, b and c value. So your a here would be equal to 9. Your b is equal to minus 12, so what's your signs? And your c is equal to minus 24. So I'll let you use the calculator in this one. The numbers are a wee bit harder, but a lot of the time this comes up in a non-calculator paper. So there's your formula, b squared minus 4ac. You're going to sub in, you're doing minus 12 squared, take away 4 times 9 times negative 24. Can you please make sure that you use brackets round, particularly round your negative numbers like this on your calculator, particularly when you are squaring. It's very, very important. If you do that, you end up with the value of 1008, which is clearly greater than 0, and in that particular scenario you will end up with 2 roots. You don't need to work out those 2 roots, you just need to go on and say, since b squared minus 4ac is greater than 0, there are 2 And you need to use the word real and also distinct roots. That's the phrase that you need to get used to. So very important that you use the terminology that's used, and that's your communication mark when you do this sort of thing in the exam. So you get 1 mark for substituting into the b squared minus 4ac, and then the other mark is for a communication. These are usually worth 2 marks, and this is how they're phrased: determine the nature of the roots. So when it's talking about nature of the roots, it wants you only to use the discriminant part, the b squared minus 4ac. You're not going on to work out the whole root, you're only working out that little bit under the square root. Now it's your turn to practice.